In this video, we're going to talk about logging. Knowing what your system is up to is pretty important. Now, fortunately, everything running in Kubernetes has a stream for outputting events or status information, standard out and standard error. The Kubernetes API makes it easy to automatically capture all of this information and send it to one place so you can make more effective use of it. The basic logging pipeline looks like this. Your application container spits out text information on standard out and standard error. Kubernetes gathers this on each node and sends it to the node log file. From there, a process running on the node can gather up all of those log lines and send them to an aggregator service somewhere else. From there, you can build analytics or a UI on top of them and present them to the user in a more usable way. One popular stack for managing all of this data is called the ELK stack. And ELK stands for Elasticsearch, Logstash, Kibana. Elasticsearch provides storage for log entries and automated indexing for fast searches, and you can run it as an application on your cluster. You use Logstash running on each node to gather up all the logs and send them to Elasticsearch. Running a pod this way is done with a daemon set, which means Kubernetes will run one pod on each node. And Kibana provides a nice UI over logs and analytics. And this also can be run as an application. Here's the default view of Kibana. Already out of the box, it provides you with an easy way to search for log entries, as well as display them in a pretty usable way. But Kibana is highly customizable, and you can turn it into a great dashboard for what's going on with your system right now. Now, this whole stack can be set up for you when you spin up your cluster. Just set kube enable node logging to true and kube logging destination to Elasticsearch when you run kube up. This will provide you with Elasticsearch and Kibana running as applications on your cluster, and Fluentd, which is like Logstash, it's a log gathering service, running as a daemon set on each node. Once your cluster is created, you can type kubecontrol cluster info to get the URL for the Kibana endpoint. Now, if you're running your cluster in the Google Cloud, you can use Google Cloud Logging. And turning this on is as easy as checking a box when you create your cluster. Google provides the storage and the gathering and the UI. All of it is pretty good, and it's all completely painless to administer. Now, if you'd rather use a third-party solution for logging, these also exist. Things like Papertrail and Loggly will provide the storage and UI for your logging needs. All you have to do is configure some kind of system for gathering up your logs and sending them to those services. One way of doing this is using the Logspout container. If you run this as a daemon set and configure it properly, it will watch every Docker container on each one of your nodes and send all of their logs to some kind of endpoint on those services. Now, one thing I should mention now that isn't quite exactly the same as logging is exceptions. Now, exceptions are not the same as logs. They include things like stack traces and context and variable definitions. This is a separate problem from capturing logging and should be treated separately, and it's really valuable when you're trying to debug a production issue. So I highly recommend using one of these systems, whether you use them in the hosted version or whether you run your own copy of them. Several of these have on-premises installations available as well. To summarize, there are three general strategies for capturing logging. If you want to run it on your own cluster, you can use the ELK stack or the EFK stack, which comes with Kubernetes when it spins up a new cluster. You can have Google manage all of your logging, or you can send your logs to an external service. Whichever one of these you choose, make sure that you're capturing exceptions separately. In our next video, we'll talk about metrics and monitoring.